Welcome. In this lesson, we are going to understand normality and the dilution law. These ideas are very important for preparing solution and performing titration. By the end of this lecture, you will know what is normality, what is equivalent mass, and how dilution affect the concentration, that is molarity. Okay, so first, normality express the strength of a solution, and it tells how much reactive species is available in 1 liter of a solution. The basic formula for the normality is number of gram equivalent divided by volume of solution in liter. So basically the unit of normality we will get equivalent liter inverse, and the formula presented in this slide is broad and the elaborated form, which easily tells you what is the unit of normality and how we will get this unit. So basically we are dividing the mass of solute, which is present in gram, by gram equivalent mass. The unit of gram equivalent mass is gram per equivalent, okay, into volume of solution, which is in liter. So if we cancel the gram of mass of solute with the gram of gram equivalent mass, we will get the final unit as equivalent liter inverse, which is the final unit of normality. Okay, so we had learned that normality is equals the equivalent per liter. This is the basic form of normality and the unit of normality. Okay, so let's move to the next slide. Okay, now to understand normality, first we have to understand what is equivalent. So equivalent is the amount of substance that react or give 1 mole of H plus or OH minus. Okay, so here in the table you can see we have taken some acids and some bases. Okay, so if an acid like HCl, if an acid like HCl give 1 H plus, so its equivalent will be 1. And if an acid will give 2H plus like sulfuric acid, so its equivalent will be 2. Similarly, if a base like sodium hydroxide will give 1 OH minus, so its equivalent will be 1. And we can write like N factor of HCl will be 1 equivalent per mole, which means 1 mole of HCl give only 1 H plus. Similarly, simply we are writing N factor for each. For HCl, N factor will be 1 equivalent per mole, as like for H2SO4, 2 equivalent per mole. For sodium hydroxide, it is also 1 equivalent per mole. That 1 hydroxide released by 1 mole of sodium hydroxide. Okay, so this is basically equivalent, and we had understood that the unit of N factor is equivalent per mole. Okay, 1 for HCl, 2 for H2SO4, 3 for like barium hydroxide, or for H3PO for phosphoric acid. Okay, so let's move to the next slide, which is gram equivalent mass. What is gram equivalent mass? Mass of a substance required to react with 1 mole of H plus or OH minus in acid base chemical reactions. Okay, gram equivalent mass formulated as molar mass of substance divided by N factor, and we know the unit of molar mass is gram per mole, and unit of N factor we had like in previous slide we discussed that equivalent per mole. So mole will cancel with the mole, and we will get final unit as gram equivalent for the gram equivalent mass. Here are in the table we can see N factor for HCl is 1 as it releases 1 H plus, N factor for H2SO4 is 2 as it releases 2 H plus, and N factor for calcium hydroxide is also 2 as it releases 2 hydroxide. Okay, what is equivalent mass? So we can say like gram equivalent mass as equivalent mass, gram equivalent mass for HCl m by 1, because we are dividing the molar mass, we are dividing the molar mass with n factor. We are dividing molar mass with the n factor. So molar mass of HCl divided by 1, that is n factor of HCl, we will get gram equivalent mass for HCl. And similarly, if we want to gram equivalent mass for H2SO4, we will divide with H2 molar mass of H2SO4 with 2. And if you want gram equivalent mass for aluminum hydroxide, we will divide molar mass with 3, because the equivalent or n factor for aluminum hydroxide is 3, and equivalent or n factor for H2SO4 or sulfuric acid is 2. Okay, so this is basically gram equivalent mass. Okay, so let's move to the next slide, which is dilution. In this slide, we can clearly see there is a chemical procedure, or I had drawn a chemical dilution. Okay, dilution process. How a dilution is proceed. What is dilution? First, it means decreasing the concentration of a solution by adding more solvent, usually water. We will always mostly add water to dilute the solution, whether it is like a alcoholic solution or any concentrated acid or any base, whether it is base or acid or any alcoholic solution. To dilute them, we will use solvent as a water. So let's focus on this diagram and this table. What tells this? In this is stock solution. We have a stock solution. So we are taking few ml of stock solution using pipette and pouring this into empty conical flask. Okay, let's take 2 ml of stock solution we had added in this conical flask. Now we are adding water. We are adding some amount of water. Let's take 98 ml. Okay, let's take 98 ml. So overall the volume of the final volume of the solution is 100 ml. It include one, like it include 2 ml of our stock solution and 98 ml of water. So we had just diluted the this stock solution with water using 98 ml. So the concentration of this previous stock solution is much higher than this, because this has been diluted using some amount, or we had just taken the example like 2 ml of stock solution and 98 ml of water. So this solution is very diluted, and the process is known as dilution. Okay, so let's talk about the dilution law in the next slide. Dilution law. During dilution, the number of equivalent remain constant. What does it mean? It means if we are using stock solution of HCl, so its equivalent is 1 in stock solution, and after dilution we have in this solution also we have HCl, so equivalent here is also 1. So during dilution there is no change in the equivalent. There is no change in the equivalent. If we are using stock solution having have equivalent 1, so in the product in a diluted solution equivalent will be also 1. Okay, so the dilution formula is basically N1V1 equal to N2V2. N1 define normality of stock solution, okay, or initial normality. N2 is the normality of diluted solution. V1 is the amount of stock solution we are using. Let's take 2 ml. And V2 is the, let's take adding 98 ml of water. So V2 will be the sum of volume of stock solution plus water. So V2 will be 2 plus 98, that is 100 ml. So final volume will be V2, initial volume will be V1, that is volume of stock solution we are using, and N1 is the normality of stock solution that is used for dilution, and N2 is the normality which is come from the diluted solution. Okay, so this is quick recap what we had learned in this chapter. Normality. What is normality? Strength of a solution in equivalent per liter. It depends on H plus and OH minus release, that is N factor. The formula we had explained, mass of solid divided by gram equivalent mass into volume of solution in liter. Okay, What is equivalent or n factor? N factor is the molar mass divided by its equivalent, and equivalent is the property of an acid or a base to donate H plus and OH minus. How much H plus and how much like OH minus donated is the equivalent. If one H plus donated, equivalent is 1. If two H plus donated, equivalent is 2. If one OH minus donated, equivalent is 1, or n factor is 1. See, you can see here, HCl n factor is 1 because it donated 1 proton, H2SO4 donate 2 protons, so n factor is 2. Calcium hydroxide can donate 2 hydroxide, so its n factor is also 2. Okay, and here m is the molar mass. Okay, so to get the equivalent mass, we will divide molar mass with the n factor. Okay, so in dilution, like adding water reduces concentration. In our previous example, we had already seen that initially we have 2 normal and finally we have 0.5 normal. Okay. Similarly, solute amount stay constant. This will not changing after dilution even. Okay. Volume increases in dilution, always volume increases. Initially we have 62.5 ml and in final we have 250 ml overall volume. Okay, so volume increases on dilution and initial equivalent always equals to final volume equivalent. As HCl has equivalent 1, so in initial N1V1, so it is also 1 in N2V2 because we are using same substance. So equivalent are always same for a same compound. And the dilution law is the N1V1 equal to N2V2. We know N1V1, N2V2 are the initial and final normality and volume respectively. Okay. Thank you for learning normality and dilution law. It was a complete revision for both normality and dilution. You can solve easily question using the above concept. Thank you for learning.